Forests are Earth's green lungs, breathing in carbon dioxide and exhaling life-giving oxygen. These majestic ecosystems play a vital role in regulating our planet's climate. They are incredible carbon sinks, absorbing and storing vast amounts of carbon dioxide from the atmosphere. Understanding how much carbon is stored in these forests is crucial for combating climate change. This is where carbon stock assessment comes in, providing us with the tools to quantify and monitor this precious resource. Carbon stock assessment allows us to measure the amount of carbon stored in different parts of a forest ecosystem. It helps us understand how forests contribute to mitigating climate change. By quantifying the carbon stored in trees, roots, and soil, we gain valuable insights into the health and resilience of our forests. Carbon stocks refer to the amount of carbon stored within an ecosystem. In forests, carbon is stored in various components, including trees, roots, deadwood, litter, and soil. Trees, the giants of the forest, are the most visible carbon storehouses. They absorb carbon dioxide from the atmosphere through photosynthesis, converting it into wood, leaves, and other organic matter. Below the surface, a vast network of roots anchors the trees and stores significant amounts of carbon. These underground structures play a crucial role in carbon sequestration, keeping carbon locked away for centuries. As trees grow old and eventually die, they decompose, returning carbon to the soil. This decaying organic matter, along with fallen leaves and branches, forms a rich layer of carbon-rich soil. Assessing above-ground carbon involves measuring the carbon stored in living trees. This is typically done by measuring the diameter and height of trees within a designated area. Foresters use specialized tools to measure tree diameter at breast height, or DBH. This measurement, along with tree height, is used to estimate the volume of wood in each tree. By knowing the wood density of different tree species, we can then calculate the amount of carbon stored in the wood. Measuring every single tree in a forest would be incredibly time-consuming and impractical. Instead, we use statistical sampling methods to estimate the total above-ground carbon stock. Estimating below-ground carbon, particularly in roots, can be more challenging. One common method is root excavation, where a small area is carefully dug up to expose the root system. The roots are then extracted, weighed, and their carbon content is determined. However, root excavation can be disruptive to the forest ecosystem. To minimize disturbance, researchers often use non-destructive methods such as ground-penetrating radar. This technique allows us to visualize the root structure below ground without disturbing the soil. By combining ground-penetrating radar with root biomass models, we can estimate below-ground carbon stocks with reasonable accuracy. Section 5. Digging deep, unveiling carbon secrets in the soil. Soil is a massive carbon sink, often storing more carbon than living trees. To assess soil carbon stocks, we collect soil samples from different depths using a soil corer. A soil corer is a long, cylindrical tool that is driven into the ground to extract a core of soil. The depth of sampling is crucial, as carbon content can vary greatly with soil depth. Once collected, the soil samples are taken to a laboratory where their carbon content is analyzed. By combining soil carbon data with soil bulk density measurements, we can estimate the amount of carbon stored in the soil per unit area. This information is essential for understanding the role of forests in carbon sequestration. Section 6. Putting it all together. Calculating total forest carbon stock. To determine the total carbon stock of a forest, we add up the carbon stored in each component: above-ground biomass, below-ground biomass, deadwood, litter, and soil. This comprehensive approach provides a holistic view of the forest's carbon storage capacity. By monitoring changes in carbon stocks over time, we can assess the effectiveness of forest management practices in enhancing carbon sequestration. For example, if a forest management plan aims to increase carbon storage, we can measure the changes in carbon stocks after implementing specific practices. This data-driven approach allows us to make informed decisions about forest conservation and climate change mitigation. As Section 7, the importance of accurate sampling, guardians of our forests. Accurate carbon stock assessment is crucial for several reasons. Firstly, it provides valuable data for national and international carbon accounting efforts. Countries use this data to track their progress towards climate change mitigation targets. Secondly, accurate carbon stock data is essential for developing effective forest management plans. By understanding the carbon storage potential of different forest types, we can implement practices that maximize carbon sequestration. Thirdly, accurate carbon stock assessment is crucial for evaluating the effectiveness of carbon offset projects. Section 8. Carbon stocks and conservation, a symbiotic relationship. Conserving and restoring forests is one of the most effective ways to mitigate climate change. Forests act as natural carbon sinks, absorbing and storing vast amounts of carbon dioxide from the atmosphere. By protecting existing forests and restoring degraded ones, we can enhance their capacity to sequester carbon. Carbon stock assessment plays a vital role in this effort. By quantifying the carbon stored in forests, we can demonstrate the value of these ecosystems in combating climate change. This information can be used to advocate for stronger forest conservation policies and to secure funding for forest restoration projects. Section 9. Conclusion. Our forests, our future. Forests are essential for the health of our planet and the well-being of future generations. Carbon stock assessment provides us with the tools to understand, monitor, and manage these vital carbon sinks. By accurately measuring and valuing the carbon stored in forests, we can make informed decisions about forest conservation and climate change mitigation. Let us all work together to protect and restore our forests, ensuring a sustainable future for generations to come.